Let me know screen is visible or not. Screen is visible.
Yes, sir. Screen is visible.
Okay. About previous problem, only detailing was remaining. In the previous class, we solved for flat slab, that is problem number 2, and in that we have done up to the check for shear, and that's the last step in the design of flat slab. And after that, you have to draw the detailing of the reinforcement, and you will skip that, and you can draw the detailing of the flat slab by referring to the problem number 1. In problem number 1, everything was completed up to the detailing of the reinforcement. And same you can do for the problem number 2. We have not done the detailing, you can do by your own. And today we will start the new topic, that is our module number, next module. The name of that module is bunkers and silos. Here we are required to design the bunkers, and also we have to design the silos. So first we will see the introductory part. What are bunkers and what are silos? The common name, the common name for bunkers and silos, common name, common name for bunkers and silos are bins, are bins. They are known as bins. Okay, bunkers and silos are known as bins. So what is the function of the bins? The function of the bins is to store the large quantity of material like grain, coal, any construction material for that matter. So the function of the bins is to store the material, store the material. So what kind of material it will store? It will store the material like coal, grain, okay, and any construction material like cement, fly ash. So the purpose of the bunkers and silos are to store these materials. Okay. And the bins, that is bunkers and silos, bins, it could be RCC and steel. It could be of RCC and it could be of steel. So in our syllabus, we will study the design of RCC bunkers and silos. This because steel design is not there in our syllabus, RCC design is there in our syllabus. So we will study the design of RCC bunkers and RCC silos. Okay. So I will show you the typical diagram of bunkers and silos, or bins we can call it. So it consists of a vertical side wall like this. Okay. It consists of vertical side wall, and then it consists of a upper bottom like this. Okay, so this is the typical diagram of the bunkers or silos. So here the materials are stored. Materials are stored. This is cylindric. This is you can call it as vertical side wall. In case of circular bunker, circular silos, it is cylindrical. Okay. So in case of rectangular bunker, it will be just a vertical wall. Uh, are you okay with the class, with the voice, with the content?
सर इनका बेस फ्लैट क्यों नहीं रहता है?
क्या हुआ?
बंकर्स का बेस फ्लैट क्यों नहीं रहता है?
हाँ बताता हूँ मैं, ये वाला बेस ना,
यस सर।
क्योंकि यहाँ पे आप डोर ओपन होता है ना, एकदम फ्लैट रहेगा तो आप उसको ओपन कैसे करोगे? अगर फ्लैट रखोगे, जैसे आपने ऐसे फ्लैट रखा, एकदम से आपको ओपन करना पड़ेगा ना। अगर आपने ऐसे रखा तो ये फ्लैप को आप ओपन कर सकते नहीं, ये ओपनिंग को आप ओपन कर सकते हो। ये छोटा सा ओपनिंग है, तो मटेरियल एकदम से बाहर नहीं आएगा अगर आपने छोटा सा ओपनिंग रखा है तो। इफ ओपनिंग इज वेरी स्मॉल, देन स्मॉल क्वांटिटीज ऑफ द मटेरियल विल गो आउट। ठीक है, यहाँ
ओके
से
सर।
जो स्टोर किया मटेरियल है ना, उसको ट्रक में भी हमें लोड करना होता है कभी कभी। हमें ट्रक में लोड करना होता है, विल टेल यू। तो हियर यू हैव कॉलम, यहाँ पे कॉलम है, कॉलम का फुटिंग है नीचे पे। ठीक है, यहाँ पे और एक कॉलम है और उसका फुटिंग है। तो यहाँ पे ट्रक आपका खड़ा रहेगा, ट्रक will be there here, and when this opening is open, the material can flow down on the, and it can be loaded on the truck. Okay, so what we have to design in the syllabus, we have to design the vertical side wall. Once again, we have to design the vertical side wall, vertical side wall, and we also have to design the hopper bottom, hopper bottom. Okay, so this is a typical figure of the bins, or you can call it as bunkers and silos. So in the bunkers and the silos, you don't have to design the column, even you don't have to design the beam. So what is expected? We have to design the vertical wall, vertical side wall, and the hopper bottom. You take bunkers, you take silos, these two things are to be designed, the vertical side wall and the hopper bottom. Okay. So we will understand the difference between bunkers and silos. Okay. Uh, Usually bunkers are very small, small bins. Bunkers are known as small bins. Small storage tank, we can call it as small storage tank or small bins. And the silos are the large bins. Large bins. Okay. Okay. So bunkers, it can be a rectangular. Bunkers can be rectangular or square. It can also be circular. So in our syllabus, we have to study the design of rectangular bunker and the circular bunker. But silos are usually circular. It is usually cylindrical. Cylindrical you can call, or you can call circular. You will not find silos or rectangular silos, square silos. You will usually find the circular silos as that is cylindrical silos. Okay. Okay. Now the difference between bunkers and silos, one difference we got, bunkers are the small bins and the silos are the large bins. So if you draw the storage tank, it is like this, right? The storage is like this. This is the vertical side wall and this is the hopper bottom. If you draw the line from this edge, if you draw the line from this edge, and this is your horizontal surface, okay? This is horizontal surface. If you draw this line from the edge of the bunker, and this angle is 90 plus 5 by 12. I will tell you what is 5. This is that angle. If you draw the straight line with respect to this angle, okay, and if that line touches the horizontal surface, if the line touches the horizontal surface, this is known as bunker. You have to take this angle and you have to draw a straight line from the edge of the bunker. If that line touches the horizontal surface, then that type of bins are called as bunkers. Same thing you have to draw like this. This is the silos. Silos are the large bins, okay? It will be larger than the bunker. Same thing you need to do. You need to draw the line from the edge of the bins. And if that line, this angle is same angle, 90 plus 5 by 2, if that line touches the opposite wall, it is not touching the horizontal surface because it is large. The height is so large. So it is touching the opposite wall. If if that is the case, if this line touches the opposite wall, then that type of bins are called as silos. What is phi? I will tell you. Phi is the angle of friction between the material stored and the concrete. Angle of friction, angle of friction between the material stored between the material stored material stored and the concrete. So basically it is the angle of friction, okay, and concrete. Okay. Something about hopper bottom. Hopper bottom is provided with the opening, okay. This is your hopper bottom, and here you have opening. It can be closed to retain the material, and if you want the material to go out, this opening is open. This is the opening. You're providing small opening here. This is your hopper bottom. Now what we say here, the angle of the hopper bottom is more than the phi. Theta is always more than the phi. Why it is so? If the angle of hopper bottom is more than the angle of friction, then materials can go out with respect to their weight. They can roll down by its own. Okay. If what if the angle is less? If the angle is less, then because of the friction, the material can be retained. Okay. So the angle of upper bottom has to be more than the angle of friction, because when the opening is opened, the materials can roll down by its own. Okay. If theta is less than phi, the material cannot come out because of the friction between the material. Because of the angle of friction between the material cannot go out. Even the opening is open. Even whatever opening you have provided, if it is open, the material cannot easily come down. It has to come down easily. For that, theta should be greater than phi. What is theta? Theta is angle of the hopper bottom, and what is phi? Phi is the angle of friction between the material. You got this? Any question? Class, any question? You got this?
No, sir.
Okay.
Yes,
So,
sir. Clear.
yes. Mustafa is there, Burhan is there. Burhan, okay, Burhan, Mustafa.
Yes, yes, sir.
Yes, sir. Yes.
Then who else is there? Mustafa, Nikhil, Danish Khan. Okay. Now, we'll talk about the design of the two things we need to design here: the vertical side wall and the hopper bottom. These two things we need to design. So we'll talk about design of rectangular bunker. Okay, we'll talk about design of rectangular bunker. Design of rectangular bunker. In the rectangular bunker, what we need to design? So you see what is there in the bunker? When the materials are stored, the material will exert lateral pressure on the wall. Okay. So pressure on the vertical wall. If you take the vertical wall, what are the possible pressure the vertical wall will be subjected to? If you take this vertical wall, it will be subjected to the lateral pressure from the material. Material will exert pressure on the wall. Okay, that is first and foremost. The lateral pressure of the material source. Lateral pressure of the material source. This is one pressure, material source. And what is another pressure? The second one is friction force between material and the concrete surface. See, there will be some friction between the material and the concrete surface. The vertical wall is of concrete, so there will be friction, and because of that friction, there you will have the frictional force, which is acting vertically upward. Okay, so this is another force that is acting on the vertical wall. First force is the lateral pressure because of the material stored, because of the material, and second is the force with respect to the friction between the material and the concrete surface. Okay, second is frictional force. Frictional force between the material and the concrete surface. Between the material and concrete surface. Okay. Now, when you're talking about the bunkers, the depth of the bunker is small as compared to the silos. Silos are the larger bins. The depth, the height of the silos will be higher than the bunkers. Okay, since when you're dealing with the bunkers, this height is small, h is small in the bunkers. Since h is small in the bunkers, we can ignore the frictional force. See, when you will get more frictional force when the height is more. Okay, so in case of bunkers, the height is less as compared to the silos. So in case of bunkers, the frictional force can be ignored, but it cannot be ignored in case of silos. When you are dealing with the silo, you need to take the frictional force into consideration. Okay, so here in bunkers, vertical wall is only subjected to lateral pressure, but it is not subjected to frictional force. It is subjected to frictional force, but because of the lesser height, the frictional force will be very small, and it can. I'll write here if you want. Since depth of the bunker is small, since depth of the bunker is smaller, frictional forces can be neglected. Frictional forces can be neglected. Okay. Now we will talk about design of vertical wall. Design of vertical wall. Design of vertical wall. Now we came to know that vertical wall in the bunkers is only subjected to lateral pressure. It is not subjected to frictional force. Okay. Okay. So before that, what you need to design in the rectangular bunker? You need to design the vertical wall. Vertical wall. This is the first design that you need to do. Second, you need to design the hopper bottom. Hopper bottom. So first we will discuss about the design of vertical wall. We came to know that vertical wall is subjected to lateral pressure. This is a vertical wall, okay? And because of the material, there will be lateral pressure. There will be lateral pressure. And how to find this lateral pressure? This lateral pressure can be found out by using a Rankine formula. Okay. So lateral pressure exerted on wall is given by Rankine's formula. Lateral pressure exerted on the wall lateral pressure exerted on the wall is given by Rankine's formula. Rankine's formula, I think you have studied in the strength of material. Praveen Salunke just came. Praveen Salunke, you were not there from the start of the class. Is given by Rankine's formula. Praveen Salunke, Rankine's formula. So Rankine's formula is P equal to gamma H cos beta. I will tell you what is gamma, what is H, and what is cos beta. Then you have cos beta minus under root cos square beta minus cos square phi divided by cos beta plus under root cos square beta minus cos square phi. Okay. And I will tell you what is gamma. Gamma is, I will write, gamma is the density of the material source, or you can call it as unit weight of the material source. So there will be some material in the bunker, and that material will have some unit weight, and that unit weight is denoted by gamma. Okay? Unit weight of the material source that is your gamma, and H is depth measured from top of the stored material. Okay, so if this is your bin, if this is your bunker, this will be the H. This will be your H. Okay, so depth measured from top of stored material. If the stored material is like this, then this will be your H. No, it will not be always horizontal. You will have some surcharge in the bunkers. Okay, so the material stored will be like this. There will be some cone shape on the top surface. So this is depth. It is depth measured from top of stored material. From top of stored material. Then what we have beta. What is beta? I will tell you. I told you, since you are providing surcharge of the material, see, this is your bin, and the material will not be horizontal. The surface of the material will not be horizontal. You will pile more materials on it, and it will form a triangular shape. So this is called as surcharge. You're piling more materials over the horizontal surface, and this angle, whatever angle it will form, this angle is known as beta, the angle of surcharge. It is called as the angle of surcharge. Beta is angle of surcharge. Angle of surcharge. And next we have phi. Phi is the angle of repose, or you can call it as angle of friction between the material. Okay, angle of repose is, and it is also called as angle of friction between the material. Angle of repose or angle of friction between the material. Okay, so this is how we have the formula, and we have seen different notation used in the formula. Okay, next we have, see, this P is acting like this. This is your material piling of the material, and this is your bunker. Okay, and P is acting in this way. P is acting in this way. But what we need the horizontal force. We need the horizontal force. We need PH. Okay, so this P is acting parallel to this surface. This is top surface of the material, and this P is acting parallel to the top surface. But we don't want P. This angle is beta. Okay, this angle is beta. We don't want P. We want the horizontal pressure exerted on the cylindrical wall. So how to find pH? pH equal to small p into cos beta. Small p into cos beta. Okay. Small p. And what is small p? Already you have seen from the Rankine's formula. Small p is, this is your small p from the Rankine's formula. Okay. And we don't want p. P is acting horizontal to the top surface. P is acting horizontal to the top surface. We want pH, that is vertical, that is perpendicular to the vertical side wall. Okay. So here we have one thing, maximum angle of surcharge is naturally equal to angle of repose. Angle of repose. So what is angle of repose? Angle of repose is denoted by phi, and angle of surcharge is denoted by beta. What we say, the maximum beta, the maximum angle of surcharge is naturally equal to the angle of repose, like this angle. Maximum beta is naturally equal to phi. Why it is so? If you provide more than this angle, if beta is more than phi, then material will start to roll down. Okay, so if beta is equal to phi, the material will be stable. It will not move down because of the friction between the material. Okay, so what maximum angle of surcharge you can maintain the maximum angle of surcharge is naturally equal to angle of repose, angle of friction between the material. Okay, if beta is more than 5, then material will start to roll down. To have the stability of the piling of material, the beta has to be equal to 5. Okay, so this thing you need to understand. So what we got, ph equal to p into cos beta, and what is p? P equal to, already we have known what is p. P equal to, again I will write here because we need to modify that, gamma h cos beta divided by cos beta minus under root cos square beta minus cos square phi divided by cos beta plus cos square beta minus cos square phi. If beta is equal to 5, what will happen to this formula? The numerator and the denominator, this will become 0. This will become 0. And this cos beta will get cancelled. So it will become 1. So what you are left with? So small p equal to gamma h cos beta. This is your small p. From this you need to find pH. So what will be pH? pH equal to p cos beta. And what is p? P is gamma h cos beta. Cos beta into cos beta, it will be cos square beta. So this is the formula of lateral pressure on the vertical wall. Okay. Up to this is clear. Any question, class? Any question you have? Do you have any question, class?
सर
Anything?
cos स्क्वायर बीटा कैसे होगा?
Cos square beta कैसे होगा? P क्या है आपका? What is P? P क्या है?
गामा एच कॉस बीटा.
गामा एच cos बीटा है ना, तो cos बीटा पहले से ही है ना यहाँ पे, तो P क्या है? गामा एच cos बीटा इंटू cos बीटा, तो cos स्क्वायर बीटा हो गया वो. ठीक है,
ओके सर.
कोई सवाल है तो पूछो. You only have 3 minutes.
क्लियर सर.
Okay, so we are dealing with the rectangular bunker. Rectangular bunker, if you see from the plan, it will be like this. Rectangular bunker or square bunker, whatever. Okay, and pH is acting like this. This is how the pH is acting. So I will take this as L, length of the bunker with respect to plan, and this is width of the bunker with respect to the plan. I'm drawing the plan of the bunker here. Okay, here also, this is pH. pH is acting like this. In the color. pH, 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 and this is pH. Okay, I will name the corner A, B, C, D. Okay, so because of the lateral pressure, bending moment will be developed in the wall. So we have to calculate the bending moment, and also direct tension will be developed in the wall. Like how you have designed the water tank. By the same principle, this a rectangular bunker has to be designed. So here we are designing the vertical wall, and that vertical wall is subjected to lateral pressure. Because of the lateral pressure, bending moment will be induced in the vertical wall, and one more force will be induced in the vertical wall, that is direct tension. Okay. One more force will be induced in the vertical wall, that is direct tension. Direct tension. So the vertical wall has to be designed for the bending moment, and it also has to be designed for the direct tension. Okay. Okay, any question you have, we will discuss in the next class. Tomorrow I cannot take class. Day after tomorrow I will take. I will take on Saturday. I will take online class on Saturday, but let me know what time is feasible. At what time I can take the class.
सर सैटरडे को ऑफलाइन लेक्चर नहीं होंगे क्या?
ऑफलाइन लेक्चर होगा ना, उसके अलावा अगर आपको फ्री टाइम मिलता है ना बीच में,
अच्छा
वो टाइम मुझे बताए आप लोग सब लोग, तो वो टाइम पे मैं ऑनलाइन लेता, ऑनलाइन लूंगा
सर
तो
ऑलरेडी
Second
सभी
half.
सर लेने वाले हैं, मस्ती सर भी लेने वाले हैं, और अभी मॉर्निंग में पाटिल सर भी बोले कि वो भी सैटरडे को लेने वाले हैं।
हाँ तो मैं आफ्टरनून में ले लेता हूँ, है ना, और मैं ऑनलाइन ही लेता हूँ क्योंकि वो रिकॉर्ड भी हो रहा है ना,
ओके सर।
बाद में आप लोग रेफर भी कर सकते हैं रिकॉर्डिंग। ठीक है, मैं आफ्टरनून में ले लेता हूँ, पर मुझे लेना
Yes,
कल
second half would be fine, sir.
कल मैं नहीं ले रहा क्लास, मैं सैटरडे को लूंगा।